IXL section S.2, identify linear functions from tables. Identificar funciones lineales de tablas. Okay, so in this IXL, we're going to be using this formula for most of the problems. Okay, this is the formula that you use to calculate the slope of a line. If you've never seen it before, I promise you, you're going to see it a lot this year in your Algebra 1 class as well as your intensive math class. Okay, so the letter M always stands for slope. The letter M stands for slope. And the formula is y2 minus y1 equals x2 minus x1. I'll demonstrate how you use it in one moment, but that's the formula that I'm going to use for pretty much every problem. I mean, some of them I'll show you how you could do mentally, but a lot of problems you're going to have to use this. So in English, the slope is the measure of the steepness of a line. If x1, y1, and x2, y2 are any 2 points on the line, the slope of the line, known as m, is represented by this equation. We're going to substitute coordinates into that equation in one moment. Esta fórmula es la fórmula para calcular el slope de una línea o el pendiente de una línea. El pendiente es la medida de la inclinación de una línea. La definición dice, dados dos puntos x1, y1 y x2, y2 en una línea, la pendiente de la línea denominada m se representa con la ecuación que está aquí. Okay, la letra m siempre representa el slope o el pendiente. Okay, ahora le voy a enseñar cómo se usa esta ecuación si no saben cómo usarlo. All right, so let me do an example first. All the questions are going to give you a table like this one with x coordinates and y coordinates. And the question for all of them is going to be, is the function linear or non-linear? That's going to be the question on every single one. Okay? Now, look here a second. It says a linear function has a constant rate of change. A linear function has a constant rate of change. A nonlinear function does not. So if it's a linear function, the rate of change has to be constant. How do you find the rate of change of a function? Okay, the way you find it is using the formula I just showed you for slope. You use that same formula to find the rate of change, which I'm going to demonstrate right now. A function has a constant rate of change if its rate of change is the same between any 2 points. All right, so let me show you what I mean by that. Let me first repeat it in Spanish and then I'll demonstrate how to do it. All right. Una función lineal. Bueno, primero que nada, todos los problemas le van a dar una tabla como la que está aquí y tienen que determinar si esto es una función lineal o no es una función lineal. Okay. Para ser una función lineal tiene un rato constante de cambio. Un rato constante de cambio. Una función que no es lineal no lo tiene constante. ¿Cómo se encuentra el rato de cambio? Espero que le estoy diciendo eso bien. Pero ¿cómo se encuentra el rato de cambio? Para 2 puntos. Se encuentra usando esta fórmula que le acabo de enseñar. Déjame enseñarle cómo es que se usa. All right, so I'm going to pick 2 points. For example, this point right here, 4, 19. And this point right here, 5, 16. Because these are coordinates. All right, 4, 19 represents a point on the coordinate plane. So does 5, 16. So does 6, 13. So let's use these 2 points. Okay, now I'm going to label them. Let's label this one x1, y1. And let's label this one x2, y2. That's a 1. Right here, this is a 1. Okay. Voy a poner que estos 2 puntos, estos números representan coordinados, ¿ok? Así que 4,19 es un coordinado para un punto. También 5,16 y 6,13, disculpa. All right, así que voy a designar que esto es x1, y1 y este es x2, y2. All right, now I'm going to substitute them into the formula. Ahora voy a sustituir dentro de la fórmula. All right, so when I do these points, right, on the top it's going to be y2 minus y1. Look at what y2 is and look at what y1 is. Fíjense cuál es y2 y cuál es y1. All right, so On the top, it's going to be 16 minus 19. On the bottom, x2 minus x1. Abajo, x2 menos x1, que sería 5 menos 4. All right, so when I do that, I'm going to get negative 3 over 1, which equals, when I simplify it, negative 3. All right, so when I check that, I got negative 3, right? Me dio negativo 3. Now I got to check if it stays the same between these 2 points, if the rate of change is the same between these 2 points. Ahora voy a chequear si el rato de cambio es igual entre estos dos puntos. Okay, so now let me label this one x1, y1, x2, y2. Listen, I'm going over it the slow way, and then I'll tell you how you could do it a little faster, all right? So give me a chance. All right, so I'm going to do the same process here. Lo estoy explicando primero de la manera despacito y correcto, y después le enseño cómo se puede hacer un poco más rápido. All right, so when I substitute it, I'm going to be 13. It's going to be 13 minus 16 on the top and 6 minus 5 on the bottom, which also gives me negative 3 over 1. Okay, eso también me dio negativo 3 sobre 1, que me da, cuando lo simplifico, también me da negativo 3. So they both gave me the same thing. And let me just demonstrate one more thing. Okay, you could also do it with this one. They got to give you, if it's a linear function, it's got to give you the same answer for all these combinations. You're not going to have to do all these combinations. I'm just showing you. Okay, si es una función lineal, te tiene que dar la misma respuesta con todas estas combinaciones. No van a tener que hacer todas estas combinaciones, pero le estoy enseñando que te tiene que dar la misma respuesta cada vez. So, oh, I forgot to label them. So let's label them. Hold on. Vamos a decir que este x1, y1 y este x2, y2. All right, so here's the formula. All right, so on the top, it's going to be 13 minus 19. On the bottom, it's going to be 6 minus 4. I want you to see it's going to give me the same answer. Me va a dar la misma respuesta. 13 minus 19 is negative 6. 6 minus 4 is positive 2. Negative 6 divided by positive 2 is negative 3. I get the same answer. Me dio la misma respuesta cada vez. Porque cuando simplifico, negativo 6 dividido por 2 me va a dar negativo 3. Okay? Now, all of this, like the explanation is right there. The explanation I just did is right there, and they're showing you if you do rows 1 and 2. By the way, these are how the explanation is going to look if you get it wrong on IXL. Okay, aquí está la misma explicación que acabo de dar, pero aquí sale como te lo va a dar IXL si coges un problema mal. Aquí dice, si haces los primeros dos, lo que te va a dar. Si haces el segundo y el tercero. I can't remember how to translate rows to Spanish, so... All right. Now look, let me tell you how you could do it a little faster. Déjame explicarle cómo se puede hacer más rápido. Basically, the way you could do it faster is just you got to do it mental math. For most of them, you could do it mental math. It's only when you get towards the end, like the challenge zone, you're going to have some tricky ones that I'll show you. That even I messed up on 1 or 2 because I was trying to go fast. Okay? La mayoría de ellos se pueden hacer en la mente si saben cómo sumar y restar bien con números positivos y negativos. Si son malos en eso, entonces a lo mejor no va a ser tan fácil. Pero solamente cuando llegamos al final hay algunos problemas que sí son, te pueden engañar, porque hasta yo cogí algunos equivocados porque estaba apurado y deben usar la fórmula que le voy a enseñar. I'm going to do a ton of examples. Okay, but look, if you do mental math, you could see you're always subtracting like this one minus this one. If you do that in your mind, you're going to get negative 3. And then this one minus this one. If you do that in your mind, you're going to get negative 3. And if you subtract like this one minus this one, you're going to get a 1 on the bottom. And 6 minus 5, you get a 1 on the bottom. If that does not make sense to you, after you use the formula a couple of times, you'll start to get the hang of it and start to see how you could do it mentally. So if you don't get that, just use the formula. And I promise you, after you do like 3 or 4 of them, you're going to get the hang of what I'm trying to say. Okay, si no entienden cómo hacerlo en la mente, porque hacerlo en la mente es simplemente hacer el proceso en la mente en lugar de escribir todo esto. Si saben cómo sumar y restar bien, se puede hacer rápido, porque en la mente puedo hacer 16 menos 19 es negativo 3, igual que 13 menos 16 me da negativo 3, y 5 menos 4 me va a dar un 1 abajo en la fracción, igual que 6 menos 5. Si no entienden eso, les prometo que cuando usan la fórmula 4 o 5 veces, se van a dar cuenta de la relación que existe y van a poder hacerlo, mucho de ello en la mente. All right, so let's look at this one. All right, so again, if I use the formula, this is an easy one to do mental math, but I'm going to use the formula. I'm going to use the formula, and you're just going to have to realize on your own how to do it mental math. It'll hit you. Let's make this one x1, y1, and this one x2, y2. All right, so on the top, it'll be 10. I forgot to write the formula. Let me write the formula first. All right, so it's going to be 10 minus 0. 10 minus 0 over 10 minus 9. That's going to equal 10 over 1, which equals 10. All right, so that gave me 10. Let me do the same thing with the bottom two and see if I get the same answer. I'm only going to do it like twice for each one, because if it works for those two, it'll work for the first and the third one. All right, so on the top it's going to be 20 minus 10. On the bottom it's going to be 11 minus 10, and you could see I get the same answer. Me da la misma respuesta. So it's linear because it has a constant rate of change. Just by checking, again, I'll say it one more time. By checking the first one with the second one, and then checking the second one with the third one, if those two are constant, the whole thing's going to be like, I don't need to check the first and the third one. It's going to be constant as well. Okay? Con chequear dos combinaciones, por ejemplo, el primero con el segundo y el segundo con el tercero. Si ya esas dos combinaciones me da la misma respuesta, entonces ya yo sé que también el primero y el tercero me van a dar la misma respuesta. Así que va a ser lineal. All right, next example. I'm going to do a lot of these, all right? Okay, so here's my formula. I highly recommend, if you're able to do IXL while you're watching this, that you do IXL while you're watching this, because you're going to get bored. It's going to be the same thing over and over again. But I'm going to do all these problems so that if you get stuck on anything, you could go through the video and find a similar problem to help you do the problem that you're stuck on. All right, so when I substitute here, I'm going to have 3 minus 5 on the top and 13 minus 12 on the bottom. That's going to give me negative 2 over 1, which equals negative 2. And when I do the bottom two, so that gave me negative 2. Let me write it down there so I don't forget. So now when I do the bottom two, x1, y1, x2, y2. I mean, you should be able to do that mental math just by looking at it. But just to write it out, I'll say it in Spanish. Arriba va a ser 1 menos 3 y abajo 14 menos 13. Se deben dar cuenta de mirarlo, que eso te va a dar negativo 2 sobre 1, que cuando se simplifica te da negativo 2. Igual que la primera combinación. Así que lineal, linear. All right, so all right, so when I do the first two, all right, on the top I'm going to have negative 2 minus negative 1. Look at the double negative signs. That's something that's very simple for you guys to mess up if you're not too sure about that. Negative 2 minus negative 1, and on the bottom it's going to be negative 5 minus negative 10. Those two negatives become a positive. Los dos negativos se cambian a un positivo. Alright, so negative 2 plus 1 is negative 1, and negative 5 plus 10 is positive 5. So the rate of change it gave me is negative 1 over 5. Now I'm going to do the bottom two. So I don't forget, I'm going to write here negative 1 over 5. Now I'll make this one x1, y1, and the bottom x2, y2. And when I plug them into the formula, negative 3 minus negative 2 on the top, 0 minus negative 5 on the bottom. Alright, so that's going to become negative 3 plus 2 and 0 plus 5. So on the top, negative 3 plus 2 is negative 1. On the bottom, 0 plus 5 is 5. So they both gave me the same answer. So it's linear. I'm going to pause the recording a second, guys. I'll be right back. All right, now for this example, all right, I believe this is one that's going to be nonlinear. Let me check. There's my formula. And let me label them x1, y1, x2, y2. The x1 always goes with the y1, the x2 always goes with the y2. El x1 siempre va con el y1 y x2 siempre con y2. So when I substitute, I'm going to have 4 minus 14 on the top and 4 minus 0 on the bottom. That's going to give me negative 10 over 4. When I simplify that fraction by dividing the top and the bottom by 2, I'm going to get negative 5 over 2. Cuando simplifico esa fracción dividiendo arriba y abajo por 2, me da negativo 5 sobre 2. All right, so negative 5 over 2 is my rate of change. Let me check the next pair. Déjame chequear los próximos dos. Before I forget, it was negative 5 over 2. I messed up here. It should be. Hold on. After this, I'm gonna jump to fractions because that's what's gonna give some of you guys issues is fractions. All right, so here's my formula. Después de esto voy a hacer fracciones porque eso es lo que le va a dar a alguno de ustedes problemas. All right, so when I plug in the values, I'm gonna get this 3 minus 4 on the top and 8 minus 4 on the bottom. As you could see, for this one, the rate of change is different. For the bottom two, I get negative 1 over 4. For the top two, I got negative 5 over 2. So this is non-linear. Okay? Este me dio dos ratos de cambios diferentes. Dos respuestas diferentes. Para los primeros dos me dio negativo 5 sobre 2. Y para los dos de abajo, negativo 1 sobre 4. Así que como no es constante, no es lineal. All right, you know what, let me just do one more like this just in case. Déjame hacer uno más como este por si acaso. All right, so I don't know why this pen is giving me trouble. All right, so we have x1, y1. All right, so there's my formula. So when I plug in the values on the top, I have 11 minus 20. On the bottom, I have 13 minus 10. That's going to give me negative 9 over 3. Negative 9 divided by 3 equals negative 3. Now, without erasing that, well, you know what? I'm going to have to erase it. It gave me negative 3. Now let me do the bottom two. All right, so for the bottom two, all right, so the bottom two, it's going to be x1, y1, x2, y2. When I plug in the values, I'm going to get 2 minus 11 on the top and 16 minus 13 on the bottom. 2 minus 11 is negative 9. 16 minus 13 is 3. So negative 9 divided by 3 will also give me negative 3. So this is going to be linear. Guys, this is one that you could do mental math. 13 minus 10 is 3, and the difference here is 1. 16 minus 13 is 3, and the difference here is 1. So it's going to be linear. The rate of change is going to be 3. I mean, there's several others that you could do mental math. But I'm just saying, like, so we don't do every single one. This one you could just mentally look at it, and you should be able to tell that the rate of change is going to be negative 3, if I'm not mistaken. Just to be sure, I'll write it out. Because I'm human and sometimes I make mistakes. But on the top, for the bottom two, it would be this over this. So this is going to become negative 1 plus 2. All right, so 13 minus 10 is 3. Negative 1 plus 2 is 1. 13 minus 10, yeah. So it's actually positive 3. I'm sorry. I thought it was going to be negative, I think. Positive 3. And then for the bottom 2, it'll be 16 minus 13 over 0 minus negative 1. That'll be 3 over, this becomes 0 plus 1. So 3 over 1, you also get 3. Instead of doing, I definitely encourage you, if you can, to do it mental math when you can. But for the sake of these examples, I'm going to use the formula. Because there's no point in saying mental math, because the people that can't see it, they need to see me use the formula. All right, so right here, x1, y1, x2, y2. So the top will be 10 minus 2. The bottom will be 4 minus 2. 10 minus 2 is 8. 4 minus 2 is 2. 8 divided by 2 is 4. So it gave me 4. Now let me try the bottom two. x1, y1, x2, y2. Here's my formula. On the top, it's going to be 19 minus 10. On the bottom, 6 minus 4. 19 minus 10 is 9. 6 minus 4 is 2. Did I do that right? 9 minus... Yeah, I did it right. 6 minus 4 is 2. So this gives me 9 divided by 2 is 4.5. All right? 9 divided by 2 is not 4. So this is going to be nonlinear because I got two different answers. And if I want to verify, let's use the first one with the third one. If I check the first one with the third one, it'll be this. Si chequeo el primero con el tercero, vamos a ver qué respuesta me da, porque cogí dos diferentes respuestas hasta ese punto. Okay, just one moment. Yeah, so I got 3 different answers with all 3 possible combinations. They all gave me 3 different answers, so this is definitely nonlinear. Okay, chequeé con las 3 combinaciones posibles y me dio 3 respuestas diferentes, así que definitivamente no es lineal. Guys, I gotta pause the recording one moment here. Sorry about that. Alright guys, now I'm going to do several problems in a row with fractions. So if you struggle with fractions, I'm going to do it like around at least 5 examples with fractions. Okay, ahora voy a hacer por lo menos 5 ejemplos con fracciones. Okay, so the steps are the same. The steps are the same. Los pasos son lo mismo. Alright, so here's my formula. Alright, so when I plug in the numbers, I'm going to have 2 1/3 minus 0 over 7 minus 5 and 3/5. Okay, now what I would recommend is, okay, I'm trying to think of the easiest way because there's several different ways to explain this, and it all depends on how good you are or not good you are at fractions. Okay, so let me try to keep it as simple as possible, I guess. Okay, on the top part, it says 2 1/3 minus 0. So let's just leave it 2 1/3. On the bottom part, we got to do 7 minus 5 and 3/5. 7 minus 5 and 3/5. I'm debating how to explain it to you guys. 7 minus... Alright, I'm going to explain it this way. Okay, I'm going to change the 7 to... I'm going to change the 7... I'm going to explain it 2 different ways, alright? Here's the first way I'm going to explain it. The first way is I'm going to change from 7 to 6 and 5 over 5. I changed the 7 to 6 and 5 over 5. What's 5 divided by 5? 1. So basically, I took away a whole number from 7 to make it 6. And that whole number, I changed it to a fraction. And that's going to allow me to do this subtraction here. Okay? Let me say that in Spanish real quick. Al 7 le quité un número entero que cambió el 7 al número 6. Y el número entero que le quité lo escribí en forma de fracción. 5 sobre 5. ¿Qué es 5 dividido por 5? 1. Ese es el 1 que le quité al 7. Okay? Now, the next question, because I used to do this in middle school, and the question would be, but mister, where did the 5s come from? Listen, I'm getting whatever number is in this denominator, I'm using that number and just writing it on the top and on the bottom. Why? Because you can only add or subtract fractions if they have the same denominator. So, whatever number is here, I wrote it here on the bottom and on the top. Again, why? Because when you write the same number on the bottom and on the top, that equals one whole number. And that's the one whole number that I took away from the 7 to make it a 6. ¿Ok? ¿Por qué escribí 5 arriba y 5 abajo? Porque estoy usando el mismo número que está en el denominador de esta fracción. Como esta fracción tiene un 5 en el denominador, puse 5 sobre 5. Si la fracción hubiera tenido el número 7, hubiera escrito 7 sobre 7. Si era un 4, escribo 4 sobre 4. If this would have been a 4, I would have written 4 over 4. If this would have been a 7, I would have written 7 over 7. Okay, now, that allows me to subtract this. The fractions, 5 over 5 minus 3 over 5 gives me 2 over 5. And 6 minus 5 is 1. So on the bottom, when I did that, I got 1 and 2 over 5. All right. Another way that you could have done that is to change them both to improper fractions. Okay. Otra manera que se puede hacer es cambiando los dos a fracciones impropio. Una fracción donde el numerador es más grande que el denominador. So this was originally 7. I just put a 1 on the bottom. 5 and 3/5. You multiply 5 times 5, which is 25. Then add this number, the 3. So 25 plus 3 is 28. 28 over 5. Okay? And we're subtracting. Now to subtract those, they got to have the same denominator. So I changed the bottom of this 1 to a 5 by multiplying it by 5. And whatever you do to the bottom, you got to do to the top as well. So 35 over 5 minus 28 over 5 is going to give you 7 over 5. Which is what you get over here when you do 1 times 5 plus 2. You get 7 over 5. And this one, when I change it to an improper fraction, I get 7 over 2. So I got 7 over 2 divided by 7 over 5. All right, now I could leave it like that if I want. If you really want to simplify it further, you could use a calculator and change it to decimals, but that's kind of a cheating way. To simplify it further, just do this. 7 over 2 divided by 7 over 5. To divide fractions, you change it to multiplication and flip the second fraction upside down. All right, so when I multiply the top times the top, I get 35, and the bottom times the bottom, I get 14. All right, and I'm just going to leave it. Well, you know what? Let me simplify it one more time. If I divide the top and the bottom by 7, I get 5 over 2. I'm going to leave my answer in that form. All right, so the rate of change between the first two is 5 over 2. Excuse me. All right, 5 over 2. Yeah, I know that may seem like a lot, but guys, you got to learn fractions, man. If you don't learn fractions, you're always going to be stuck. As soon as you get fractions, you're going to be stuck. It seems like a lot, but I did it. You could do it. I've had tons of students that are able to do this, all right? So if you never properly learned how to do fractions, why don't you do yourself a big favor and learn now? Otherwise, it's going to keep bringing you down for the rest of this year and the rest of next year and the rest of the following year. Why don't you just fix the problem right now? I'm going to do several examples in a row. They're all more or less the same, okay? And I still got more to do on this one, okay? When I do the second and the third one, I'm going to explain it in Spanish, since I did this one in English, okay? Ahora voy a hacer lo mismo que acabo de hacer, pero con el segundo y el tercero, y lo voy a explicar en español, okay? Si nunca aprendieron bien cómo usar fracciones, apréndenlo ahora, porque esto va a seguir saliendo el año completo y el próximo año y el año después. Así que apréndenlo ya, porque es muy importante. Alright, so remember, 5 over 2. Ok, la respuesta que me dio era 5 sobre 2. Déjame escribirlo aquí. All right, so now let's do this one. X1, Y1, X2, Y2. They're not all going to take this long. I just went long on the first one because I was trying to explain everything properly. All right, so here's my formula. All right, believe it or not, I could do this one quick. Let me show you how you could do this one quick. Este se puede hacer rápido. Okay, look at the fractions. 2 over third minus 1 over third is 1 over 3. I said I was going to do this in Spanish and I kind of didn't do it. Miren las fracciones. 2 sobre 3 menos 1 sobre 3 me da 1 sobre 3. And 4 minus 2 is 2. 4 menos 2 me da 2. Down here, all right, this one you should be able to see this. 8 and 2/5 minus 7 is 1 and 2/5. Because 8 minus 7 is 1, and 2/5 minus, there's no fraction here, is 2/5. Okay, 8 y 2 sobre 5 menos 7. El 8 menos 7 me da 1, y 2 sobre 5 menos, no hay ninguna fracción aquí, me da 2 sobre 5. Okay, now when I change that to improper fractions, lo cambio a fracciones impropio. Esto sería 7 sobre 5 y el de arriba 7 sobre 3. So 7 over 3 divided by 7 over 5. Because that's what this means. Ok, esto quiere decir división. 7 sobre 3 dividido por 7 sobre 5. Y para dividir fracciones siempre se cambia de división al signo de multiplicar y la segunda fracción se pone al revés, se pone el recíproco. ¿Ok? Ahora multiplico el de arriba por el de arriba y el de abajo por el de abajo, que me da eso. Y ahora si divido arriba y abajo por 7 para simplificarlo, if I divide the top and the bottom by 7 to simplify, me da 5 sobre 3, que no es lo mismo que tenía antes. That's not the same thing I got before. 5 over 3, 5 over 2. So look, this is nonlinear. Do you think you would have figured that out without doing all this? I mean, of course, you could have guessed. But if you keep guessing, it's going to keep bringing you down. You may get one right, but you're going to get the other one wrong. And then you're going to keep being brought down. And remember, you got to get to 100 points. All right? So you're never going to be able, this is a perfect example of why I'm forcing you guys to get to 100. Because if I don't, you'll just skip or guess on the fractions until you get to some lower number. You got to learn fractions, period. Tienen que aprender cómo usar fracciones. All right, next example. All right, so I think by this time, do I need to label them? Just in case, I will. So on the top, it's going to be, whoops, almost messed up. On the top, it's going to be 0 minus negative 8. On the bottom, it's going to be 1 1/5 minus negative 2 over 5. All right, so the two negatives become a positive. Los dos negativos se cambian a positivo. All right, this one's actually pretty simple to do. 0 plus 8 is 8. And on the bottom, 1 over 5 plus 2 over 5 is 3 over 5. And the 1 stays. Okay, now I'm going to change the 1 and 3 over 5's. I'm sorry, let me say that correctly. I'm going to change the 1 and 3 over 5 to an improper fraction, or 1 and 3/5 to an improper fraction by doing 1 times 5 plus 3. And I keep the 5 on the bottom. Okay, now that's 8 divided by 8 over 5. 8 divided by 8 over 5. 8 dividido por 8 sobre 5. Change the 8 to a fraction by putting a 1 on the bottom. Now, in order to divide fractions, I multiply by the reciprocal. And that's going to give me, the 8's cancel out. But just for the people that are not good at this, let me go slow. 4 divided by 8 is 5. All right, so the rate of change is 5. Let me check for the second pair. Okay, me dio 5. Déjame chequear para los próximos dos. All right, so if anything, this will help you. If you're writing this will help you remember or memorize the formula. All right, so on the top it's going to be 4 minus 0. On the bottom it's going to be 2 and 4 over 5 minus 1 and 1 over 5. All right, so 4 minus 0 is 4. Okay, on the bottom, 4 over 5 minus 1 over 5 is 3 over 5. 2 minus 1 is 1. And I'm going to change the bottom one to an improper fraction, which will be 8 over 5. So now I got that. So that means 4 over 1 divided by 8 over 5. Para dividir fracciones lo cambio de división a multiplicación y multiplico por el recíproco de la segunda fracción. All right, when I multiply that, I get 20 over 8. That's not going to equal 5, so I could stop. All right, 20 over 8, when I simplify by dividing the top and the bottom by 4, I'll get 5 over 2. And that does not equal 5, okay? Esto no me dio la misma respuesta, me dio 5 sobre 2. So that's nonlinear. All right, let's look at this one. Okay, so x1, y1, x2, y2. So on the top is going to be 2 minus 1 half. On the bottom it's going to be 4 minus 1. 2 minus 1 half is 1 and 1 half. And 4 minus 1 is 3. I can make this complicated and go through every step. Here, I'll do it. Okay. I wrote the question wrong. And I don't know how to erase without erasing the whole thing. All right. You can think about it like this. 2 over 1 minus 1 half. You got to change the 2 over 1 to a fraction that has a 2 on the bottom by multiplying bottom by 2. And whatever you do to the bottom, you got to do to the top. So 2 over 1 is the same as 4 over 2 because 4 divided by 2 is 2. Now, 4 over 2 minus 1 half will give you 3 over 2. And 3 over 2 is the same as 3 over 2 is the same as 1 and 1 half. All right. If I divide 3 by 2, I'll get 1, remainder 1 half. Okay, anyways, I probably shouldn't have done that, but all right, so 1 and 1 half divided by 3. Oh, first, before I do that, let me change 1 and 1 half to an improper fraction. It's going to be 3 over 2. So 3 over 2 divided by 3. 3 sobre 2 dividido por 3. Change the 3 to a fraction by putting a 1 on the bottom. Cambien el 3 a una fracción poniendo un 1 debajo. Now to divide fractions, I change it to multiplication and flip the second fraction upside down to its reciprocal. Para dividir fracciones lo cambio a multiplicación y pongo la segunda fracción al revés para que sea el recíproco. So I'm going to have 3 over 6, which when you simplify it is 1 half. All right, so the answer for the first two, the rate of change is 1 half. Okay, para lo primero dos me dio 1 sobre 2. Now let's check these. Guys, for the sake of hurrying it up, I'm just going to do without writing the formula. On the bottom it's 10 minus 4. 10 minus 4. So 3 over 6, which is 1 half. All right, so they're both the same, so it's linear. Linear. All right, even I'm getting a little tired here. Okay, but I was teaching like in between this. You guys just didn't see it because I paused the video. All right, so all right, so let's make this one x1, y1, x2, y2. So on the top it's going to be 0 minus negative 9 and 1/3. On the bottom it's going to be 2 minus negative 1 half. 2 minus negative 1 and 1 half. All right, so the negatives become a positive. The negatives become a positive. So on the top, you're going to get 9 1/3 over 3 1/2 on the bottom. Now let's change them to improper fractions. Lo voy a cambiar los dos a fracciones impropio. So 9 times 3 is 27, plus 1 is 28. Divided by, the bottom one is 3 times 2 is 6, plus 1 is 7 over 2. So now I change the division to multiplication, the second fraction to its reciprocal, and I'm going to have 56 over 21. 56 over 21. All right, and 56 divided by 21. Isn't this fun? All this work. All right, 56 divided by 21 is, oh, no, it's 2. Wait, let me make sure. Yeah, it's 2. All right, so I'm going to have 56 minus 42, remainder 14. All right, so the remainder goes here as the numerator, and the number you divided by, you put as the denominator. And when you simplify the 14 over 21 by dividing the top and the bottom by 7, you're going to get 2 2/3. Whew, that was a lot of work. Or maybe I'm just tired. All right, so 2 2/3 is my answer. Let me check the bottom two now. 2 2/3. I'm writing it there so I don't forget. All right, so if I do the bottom two, to save time, I'm not going to write the formula. 9 1/3 minus 0 on the top, 5 1/2 minus 2 on the bottom. On the top, that'll give me 9 1/3. On the bottom, that'll give you 5 minus 2 is 3, plus that 1/2. Whoa, look at that 3. All right, there's better. 3 1/2. Okay, now let's change them to improper fractions. Lo estoy cambiando a fracciones impropio. All right, so 28 over 3 divided by 7 over 2. The division becomes multiplication. And the 7 over 2 becomes 2 over 7. 28 times 2 is 56. And 56 divided by 21. I'm pretty sure this is the same thing I got last time. Yeah, it is. 56 divided by 21 will be 2. 2 times 21 is 42. The remainder is 14. So 2 and 14 over 21, which equals 2 2/3. So they both gave me the same answer, so linear. Let me see how many more examples I got. All right, 3 more to go and I'll stop. 3 more. All right, so me faltan 3 ejemplos más que voy a hacer con fracciones. All right, so this one, again, I've written the formula like a million times, so I'm just going to write, it's this one minus this one. If you don't know it by now, after like 20 times that I've written it. And on the bottom, 7 minus -9. Okay, so on the bottom, it's going to become 7 plus 9, which is 16. Okay, on the top, when you have a negative number and you're subtracting, quick little example. When you have a negative number minus a number, when you have a negative number minus a positive number, or a situation that looks like this, you always end up adding them together and it stays negative. I don't know what's the best way to describe what that says there, but if you see it, all right, like here's another example. -3 minus 2 is -5. You end up adding them and it stays negative. So that's what I'm going to do here. I'm going to add them, but it stays negative. I am subtracting, but that's how you get the answer. 7 plus 8 is 15. And 1 plus 2 is 3. This 3 over 3 is 1 whole. 3 sobre 3 es uno entero, porque si divido me da 1. So really, that gave me -16. And -16 divided by 16 is -1. All right, so the rate of change is -1, negativo 1. Now let me check it with the bottom two, with these right here. All right, so it's going to be -10 minus -7 1/3 over 9 2/3 minus 7. -10 plus 7 1/3 over 9 2/3 minus 7. All right, so on the top, -10 plus 7. Okay, So negative 10 plus 7 is going to be 17 plus this 1/3. Negative 10 plus 7 is going to give you 17 plus this 1/3. On the bottom, 9 and 2/3 minus 7 is going to give you 2 and 2/3. Obviously, there's no way this is going to give you negative 1 or any sort of 1 because they're two completely different numbers on the top and on the bottom. All right. I'm just double checking my numbers to make sure I didn't make a mistake. Negative 10 minus negative 7 and 1/3. 9 and 2/3 minus 7. No, I did it right. So, yeah, this is nonlinear. Okay, now let's look at this one. This one and one more and I'm done. Okay, so, all right. This one is going to be linear. Look, this one we could tell just by looking at it, it's going to be linear. Let me show you why. Esta de mirarlo se puede ver que va a ser lineal. Déjame explicarle por qué. Okay, look at on the top, it's going to be 1 and 3/5. Let me just write this for a second. X1, Y1, X2, Y2. All right, so the formula is this. Y2 minus Y1 over X2 minus X1. So on the top, it's going to be 1 and 3/5 minus negative 9 and 3/5. And on the bottom, it's going to be the same exact thing. Okay, so whenever you have the same thing on the bottom and on the top, I mean, I could go and work all of this out. Whatever answer it gives you, it's going to be the same number divided by the same number, and that always gives you 1. Same thing with the next pair. If I do the third row with the second row, it's going to be this. Always the same number divided by the same number, or the same thing divided by the same thing, always has to give you positive 1. So this one you could do it just by looking at it. Siempre el mismo número dividido por el mismo número te tiene que dar 1. ¿Ok? Y como tengo lo mismo escrito arriba y abajo, cuando lo divido el resultado me tiene que dar 1. No importa qué número me da estas calculaciones. Alright, let's go to the last example, el último ejemplo. Alright, so on the top it's going to be negative 5 minus 2. On the bottom it's going to be 8.5 minus negative 9. Alright, that's going to be on the top negative 7. Remember my little technique. You add them and it stays negative. That way you could just look at it and do it. On the bottom, 8.5 plus 9 is going to give you 17.5. Now let me change 17.5 to an improper fraction. This will be 30. 17 times 2 is 34. 34 plus 1 is 35. On the top I got negative 7. So negative 7 divided by 35 over 2. I'm going to change the division to multiplication and flip the second fraction upside down. And let's make the negative 7 a fraction by putting a 1 on the bottom. So this is going to give me negative 14 over 35. Now to simplify, divide the top and the bottom by 7. Para simplificar, dividen arriba y abajo por 7. And that's going to give me negative 2 over 5. So that's my rate of change for the first two rows. Negative 2 over 5. Now let me check the bottom two rows. Ok, para primeras dos me dio negativo 2 sobre 5. Ahora déjame chequear los dos de abajo. On the top, negative 7 minus negative 5. On the bottom, 10 minus 8.5. The top becomes negative 7 plus 5. The bottom, let me just leave it like that for now. So on the top, negative 7 plus 5 is negative 2. On the bottom, 10 minus 8.5 is 1.5. What's 10 minus 850? 150. If you still don't see that, 10 minus 8 and 1/2. I'm going to change the 10 to a 9 and 2 over 2. Si cambio el 10 a 9 y 2 sobre 2, que quiere decir la misma cosa. Now I can do 2 over 2 minus 1 over 2 is 1 over 2. And 9 minus 8 is 1. Okay, so now I got this. Let me change the 1.5 to an improper fraction by multiplying and adding. So it's going to be 3 over 2. So negative 2 divided by 3 over 2 becomes negative 2 over 1 times 2 over 3, which becomes negative 4 over 3. So that Eso no es lo mismo que esto. I did not get the same answer. So therefore, it's non-linear. All right, guys, so there you have it. I did a ton of examples with fractions. If you have anything with fractions, all right, don't complain that it's too hard. You're in high school now. You got to learn this. You should have learned it in middle school. All right? There's middle schoolers that totally understand fractions. You could do the same thing. Fix it now. If you have a problem, the only way you're going to fix this problem is by actually doing. Look at me. Look at all the work I did. Did I complain? Maybe a little. But I did it. Okay? So don't complain. The only way you're going to learn something is by going through the hard work. All right? Not every problem is going to be a little baby problem that you could just, pick multiple choice answer. If you truly want to learn and stop struggling, you got to do the work required and you'll get it. Trust me. It's not magic. The people that understand math and are good at math is just because they've already done the work required and gotten enough problems wrong that now they realized, oh, that's what I was doing wrong. Now I understand. But that's the only way you're going to figure stuff out, okay? Sí se tiene que hacer para la que tiene fracciones y para otros también. A veces se tiene que hacer mucho problema, pero es necesario para aprender cómo usar fracciones. And by the way, I just remembered that there's some tricky problems that I missed, but that I forgot to do examples of. However, when I say tricky, I just mean that when you look at them, they look like they're linear, but if you do the actual work using the formula, which I demonstrated like a ton of times in this video, you'll see that you don't get the same answer. All right, so if you get something wrong, don't message me, why am I getting this wrong? Use the formula and you will see that you don't get the same answers. All right, so if you get it wrong and you didn't put in the work, don't message me. Now, if you put in the work and you got it wrong and you don't get why, feel free to message me so that I can look at your work and tell you what you did wrong. All right, but don't message me unless you have the work worked out so that I can analyze where you're going wrong. Okay? Si cogen algo mal y no entienden por qué y me van a mandar un mensaje, quiero ver las calculaciones escritas para yo poder enseñarles dónde es que están haciendo algo mal. Okay, pero si simplemente lo están mirando y adivinando, no me pregunten por qué lo están haciendo mal si no me están enseñando el trabajo que hicieron para coger las calculaciones, porque eso es de la única manera que les puedo enseñar qué es lo que están haciendo mal o qué es lo que no están entendiendo bien. All right, guys, there you have it. Make sure to get to 100 points on that IXL. Have a great day.